analysis models represent systems that can be constructed from components. Simcenter 3D supports this concept through Assembly FEM. A benefit of Assembly FEM is that multiple users or batch processes can construct component meshes which are later brought together in an assembly. But what if your components contain loads and boundary conditions? Wouldn't it be nice to have a component feature for them in a similar manner as what exists for component meshes? Simcenter 3D supports that concept through collaborative simulation. It enables efficient definition and management of component loads and boundary conditions for use in an assembly. Let's take a look. We start with an assembly FEM of an aero engine consisting of 3 components and a simulation that has no loads or boundary conditions. There's a component for bolts, another for the high pressure turbine section, and a third for the compressor. Now let's switch to the high pressure compressors simulation. I'll turn on the display of the loads in the compressor. The loads are organized by folders. I have a folder for streams on faces, another for convecting zones, streams on edges, voids, and then I have a rotation load. So there's a lot of load data in this model. And it would be nice to share this information in the assembly. So let's do that next. I'll open the Simulation Interface Manager from the Simulation Navigator, and you'll see I have 2 tabs, one for exported simulation interfaces and another for imported simulation interfaces. In the component, we're going to create an exported simulation interface. So we do that now. Going to present a dialog in which we have an entity list where we will select objects to share with the assembly simulation. So I'm going to call this HPC Mission 1, and we're filtering by our solution of interest, looking at all entities, and then select the rotation load, these void folders, stream, convecting zone, stream on face, and then some of the constraints and simulation objects as well. And then I OK out of the dialog, and this will give me another container. So I have a simulation interface container, and I have my exported base object there. Now I will go into the assembly's sim and import interface objects from the compressor and the turbine. Import objects, much like exporting, just in reverse, and I can pick the component simulation and the interface object of interest. I'll go ahead and say OK to the dialog, and you can see it's highlighting the component, and now we have the loads in our assembly sim and the simulation objects and constraints as well. We have this new column indicating a link status. So these are all green. They are up to date, and I have a new imported simulation interface object. So in order to add those to the current solution, I'm just going to select them and say Add to Active Solution. Do that for the constraints and the loads as well. Turbine's interface object was added to the assembly model also. Now let's look at updating content from the component simulation and applying those changes to the assembly's simulation. So we switch into the compressor simulation, and we're going to modify the stream 1130 on that last dip. We're going to change the swirl input type from being defined with a ratio to that of a velocity, and you see our expression based on radius and NH, a condition parameter. So I say OK to that, and then go back up into the assemblies simulation. And first thing we notice is the interface object from the compressor has gone out of date. We have an update to our status. It's telling us that we need to update, and we can go down into the particular folder that contains that stream, and we see that that stream is in need of an update. And then we can also edit that stream just to give an idea of what edit is like in terms of an imported interface object. In fact, you can't edit any of these objects. These are just read-only type of objects when they're being imported. So I can't make any changes to selections, I can't make changes to expressions or any of the parameters of this load. So what I'm going to do now is go ahead and update this, and then we'll see after I update that load has the definition of its swirl velocity, a swirl input as a swirl velocity with the correct expression from the component simulator.